All right, welcome everyone to the PRIMA workshop for the Geo Book Volume 2. I'm going to be providing an overview of PRIMA and the science that is designing it. Jason Glenn, our PI, is from Goddard. I'm Margaret Meixner. I'm the deputy PI, and we have Matt Bradford, Alex Pope online, who are in the leadership team, and of course we have Betsy, who's our communication lead. Okay, so PRIMA is really going to be a general observatory. 25% of the observing time is for principal investigator science that I'll go over. And this science is basically defining the capabilities of the observatory, but 75% of this observatory will be for you, the general observers. Also, the PI data from the programs I'm going to describe will be available quickly for guest investigator programs. What is PRIMA hardware-wise? It's a 1.8 meter all aluminum telescope, but most importantly, it's at 4.5 Kelvin. So it's a very cold telescope. The Primager instrument has low resolution spectroscopy and photometry that Mark Savage will talk about. And Matt Bradford will talk about the FIRA spectrometer, which has two capability modes. And probably for the first time, we're getting this full spectral coverage, 24 to 235 microns very quickly, very powerful spectroscopically. The one miracle we have are the kids, and the kids are working very well. IPAC will be the data center, and it will be at Earth Sun L2, and it will launch in 2032. So big thing is that there'll be large gains in new capabilities due to the kinetic inductance detectors. So kids have now reached the sensitivities such that coupled with this actively cooled mirrors, observations are only limited by the astrophysical background, that is the zodiacal light. And so that's like if you're an optical astronomer, if you try to observe stars in the daytime, it's difficult, but you can see them at night. So cooling the telescopes make the far infrared sky visible. On the right, we show the spectral coverage as well as the huge gain in sensitivity that we have over prior facilities of Herschel and Sophia. And this is shown in spatial spectral survey time. PRIMA will be capable of both photometric and spectroscopic surveys. The PI is organized around three themes: how planets get their atmospheres, how black holes and galaxies evolve together, and how dust and metals build up in galaxies. And so these three themes are captured at the high level here, and as well as the fact that it's really a guest observatory. So let's delve into it a little bit. For planets, growth in disks. So the top shows a cartoon of how planets might form and also the location of where planets may form. You get your in situ atmosphere. And so the question is, do the abundances of carbon and oxygen map to the stellar metallicity? So PRIMA is going to use the deuterated hydrogen line to determine accurate gas disk masses for absolute abundance measurements. And we'll be able to investigate basically the origin of those atmospheres. Do icy pebbles drive planetesimal accretion? So PRIMA will observe the water vapor lines and the distribution in the disks, and you can see on the right that water is a very dominant spectrum, has a dominant spectroscopic signatures in the far infrared, including the water ice. Galaxy evolution, what is the relationship for black hole accretion rate and star formation rate in luminous galaxies since the peak epoch of galaxy growth? That's around Z of 2. And so here we have the origin of these scaling relations. We know that today galaxy mass and black hole mass are correlated, but then how did it get there? And that's what PRIMA is going to pin down, starting at this peak epoch of this growth. On the right, we're showing how we'll be able to differentiate between the quite different approaches from fast black hole growth to slow black hole growth. So PRIMA, how is it going to do it? It's going to measure the redshifts, black hole accretion rates, and star formation rates for 42 1,000 galaxies in 1 square degree and make spectroscopic subsamples of 160 from Z of 1 to 2.5 using the oxygen 4 and the neon 2 line. And those are breast-framed signatures for black hole accretion rates and star formation rates. It's also going to use PRIMA's going to measure the mass outflows in 50 galaxies using the OH line of R of 900 at 84 microns, and this absorption to test if they're actually, these outflows are actually quenching the star formation rates. Third theme, looking at the rise of dust and metals, has the relationship between polycyclic aromatic hydrocarbons, or PAHs, and metals evolved since cosmic noon. So locally, there's a known reduction in pH emission with reduced metallicity. And the question is, does it look the same or does it have a different characteristic? And so for 100 galaxies, we're going to be measuring these spectra that will show us the metallicities via the oxygen and nitrogen lines, and QPA, which is a measurement of sort of the total amount of PAHs in the body of dust. And then we have on the right showing how the spectrum of a star formation galaxy with these features get redshifted into the PRIMA band as you go towards cosmic noon. Okay, last but not least, but we will also be using polarized emission to do a study of local galaxies to give us information about their dust composition in the interstellar medium. Okay, so just to end here, 75% of PRIMA's time is dedicated to the general observer science. That's you. PRIMA surveys defined mission requirements. The goal is to create a powerful, flexible set of observatory capabilities that enrich the program of the community science. And we want PRIMA to be your observatory. You can help us by starting early to define the science you would perform with PRIMA. This helps ensure that your scientific needs can be met with this observatory and demonstrates the community needs for this facility. So all of the PI data will be public after initial validation. In addition to the geo cases, we welcome examples of the GI cases that would use these PI surveys. And then to assist you in thinking about these things, we are launching these PRIMA science working groups this week. Initial coordination will be through Slack, so watch your email for an invitation to join and select these working groups. There's also still time to sign up. And these are all the working groups, and then we have some that have leads and others that are coming with leads. And I will stop there. On to the next presentation.